Hey, how you doing out there? Well, we had some requests for some more help on these mono and dihybrid crosses, Punnett squares. So I'm gonna do some. All right, so here's number two. Remember, you got to know these terms: homozygous, heterozygous, hybrid, true breed, pure breed. All right, so here, big B, black is dominant. Little b, white is recessive. So if you have two big B's, you have black fur. If you have one big B, you'll have black fur. The only way you can have white fur is you can have two little B's. But anyways, homozygous black. If you don't know what homozygous means, you're in trouble. But I know what homozygous means, so I'm not in trouble. Homozygous means same. So this rabbit is big B, big B. The other rabbit has white fur. Well, it doesn't even have to say homozygous because the only way you can have white fur, you got to be little b, little b. All right, I found the genotypes of the parents. So here's the allele. Let's say the alleles for, say, like the dad rabbit. Here's like the mom rabbits. So I'm going to put the dads on top. So he can give either the big B allele to his babies, or he can give his other big B allele. They're the same, so it really doesn't matter. They're both the same. Just, the other one's going to be the same thing. The mom rabbit has two of the same alleles. She's homozygous, little b, little b. And then it's just filling in the boxes. So right here, get rid of that thing. First one will be big B, little b. And you can probably see that they're all going to be big B, little b. I should have done that. Anyways, they're all going to be big B, little b. So trust me, that I can't get rid of this box. So, man, I can't get it out of there. Anyways, this one's going to be big B, and big B as well. So the all four. 4 out of 4 is going to be big B, little b. So the genotypic ratio is 4 out of 4, or 100% will have the genotype of big B, little b. They'll all be heterozygous. Now, what are these rabbits going to look like? Well, since they all contain one big B, they're all going to have black fur. So 100% of the rabbits will have black fur. I'm going to skip this one because you're not going to have one of these on the test. It's basically asking you to cross two of these, a big B, little b, with another big B, little b. But we need more practice with these terms. All right, so here we got another one, rabbits again. Heterozygous black. If you know what heterozygous means, you have a chance. If you don't, you got to flip a coin. And then you just got to get lucky. But it's better to be good than lucky. All right, so heterozygous means different. So this rabbit's going to be big B, little b. We'll say that's the dad rabbit. He's got black fur. The mom is homozygous black rabbit. They look exactly the same, but this one's homozygous, so she has a different genotype. Homozygous means same, so she's going to be big B, big B. All right, so you put either one of the alleles. I'm going to put the dad rabbits on top. You can give the big B allele to his little baby rabbits, or you can give the little b. The mom, she has two of the same alleles. She's got big B, or she's got another big B. Got to get rid of this thing. It's killing me. How do I do that? There we go. All right. Now, since both of these B's are the same, this row or this column or whatever is going to be the same as the bottom one and the top one are going to be exactly the same. So you don't have to do it twice. So let's scratch it out because, these are both big B's. Because 2 out of 4 is going to be the same thing as 1 out of 2. They're both 50%. So this one's going to be big B, homozygous, dominant, just like the mom. And this one's going to be big B, little b, just like the dad. Genotypic ratios. How many of them out of 2 are big B, big B? I see 1. So 1 out of 2 will have the genotype of big B, big B. And the other one on the top right, 1 out of 2, will have the genotype of big B, little b. Phenotypic ratio. That's just asking, hey, what are these rabbits going to look like? Well, since both of them have at least one big B, it does not matter if you have 1 or 2 because black is dominant. So all those rabbits, 100%, are going to be black fur. All right, let's try plants. Big T is for tall, little t is for short. So here we go. Step 1, find the genotype of the parents. And the first parent is tall hybrid. He's a tall hybrid plant. If you know what hybrid means, you got a chance. If you don't, it's time to go eeny, meeny, miny, mo, and try to get lucky. Here we go. Hybrid means different. So it's a big T. Oh, where'd it go? Big T. What's wrong with my keyboard? Big T. There we go. Little t. Now we're going to cross it with a short plant. If you see there, short is recessive. The only way you can be a short plant since it's recessive, you got to be little t, little t. Found the genotype of the parents. Now we're in business. All right, I'm going to put this plant right here on the top. It doesn't matter. You can put, doesn't matter which one you do. Big T, you can give the big T, or the plant can give the little t. The other plant, I'm going to draw it because I get that box gets in the way. Can give the little t. I don't like that. Or it can give the other little t. Pretend like they're the same color. Now, once again, since these are both little t's, we don't need to do it twice. We can cross out this box. Now, we can't cross these out because they're different. So now we just fill in the boxes. This is going to be big T, little t. This will be little t from the top, little t from the side. Genotypic ratio. 1 out of 2, or 1/2. We'll have the genotype of big T, little t. And 1/2, or 50%, we'll have the genotype of little t, little t. Offspring's phenotypic ratio. Since this guy right over here in the top left, since he has a 1 big T, that's all you need, since tall is dominant, half of them will be tall. And this other guy in the top left, he's got 2 little t's, 2 recessive alleles. So that's going to make him 1/2 will be short. This one, cross 2 heterozygous plants. Ooh, this will be a really bad one for you on the test. They're heterozygous because if you don't know what heterozygous is, once again, it's going to be, you're just going to be guessing. But we're using t's again. And you should know heterozygous means different, just like hybrid. So we're crossing a big T, little t with another big T, little t. All right, so now they both have the same genotype. They're both heterozygous hybrid. I'm going to put their alleles. So this plant can give its babies either the big T or the little t. That's Mendel's principle of segregation. He does not give both. He gives one or the other. Same with the other parent plant. I'm going to draw it. I hate when that box gets in the way. All right, so this one can also give the big T, or it can give the little t. Boom. Now we got the genotypes of the parents, and we got their alleles. Here's their possible alleles they can give. I'll just fill in the boxes. Big T, big T. Big T, little t. Get that out of the way. All right, there we go. Big T, and little t, little t. Genotypic ratio. Now, we couldn't cross any out here because, look, big, little, big, little. None of them were repeats. None of them were the same, so we had to fill in all 4 boxes. But anyways, top left over here, 1 out of 4 now. 1 out of 4 will have the genotype of big T, big T. Now, this one over here and this one right here, those are both big T, little t, and there's 2 of them. So 2 out of 4, or 1/2, or 50%, will have the genotype of big T, little t. And the last one, the guy on the bottom right, 1 out of 4 chances, nope, not 2, 1 out of 4 chances of getting the genotype of little t, little t. Phenotypic ratio, all that's saying is, hey, what do these plants look like? All right, this one has 1 big T, it's tall. This one has 2 big T's. It's the same, it's tall, because big T's dominant. It's not taller. All you need is 1 big T. And this one's also going to be tall because it's got 1 dominant tall allele. So that's 1, 2, 3. 3 out of 4. Nope. 3 out of 4 will have the phenotype of being tall. And the one on the bottom left, the little t, only 1 out of 4 on average will have the phenotype of being short. Boom. All right, now we're on to the dihybrids. That one's too easy, so I'm going to skip it. That one's too hard, so I'm going to skip it. I'm going to do 3. Actually, we've done 3 before. Let's do this one. Heterozygous yellow, homozygous wrinkled. So now, remember up here, our genotypes were only 2 letters, and this guy had 2 letters. But that's because we're looking at only 1 trait, either tall or short. Now we're looking at two traits, their color and whether they're long or short. Oh, actually, we're doing this one. So we're looking at seed color, yellow or green, and we're also looking at seed, like is it round or is it wrinkled? So now we're going to need 4 alleles in the genotype because we're not looking at just 1 trait, we're looking at 2. Anyways, step 1, find the genotype of the parents. And also, you do not have to do the possible gametes because you're going to show me that right here, 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 and on the sides. These are the possible allele combinations in the gametes. So the parent's genotype. Heterozygous yellow. If you know what heterozygous means, you have a chance. If you don't, once again, you're just guessing. So heterozygous, you should know, means the same as hybrid. It means different. So I need a big Y and a little y. Those are different. And now this plant is also homozygous wrinkled. Homozygous means same. And look, wrinkled is recessive. So it didn't even have to say homozygous because the only way you could have wrinkled seeds, you got to have little r, little r. Boom, we found the genotype of that plant. Notice it's 4 letters, 4, not 2. I'm gonna go over here. The second plant. He's purebred green. Purebred green. Now you shouldn't even have to be lucky on this one. If you don't even know what purebred means, it means the same. Just like homozygous, just like true breed. It means same. But look, green is recessive. So the only way you could have green seeds is you got to be little y, little y. The second one's also, his seeds are hybrid round. Hybrid round. If you know what hybrid means, good job. If you don't, I mean, you're kind of wasting your time here. Hybrid round, hybrid means the same thing as heterozygous. It means different. Big R, little r. Those are two different alleles. Big and little, that's different. All right, now the confusing part. We got to find out all the possible allele combinations. So above each one of these rows, I need two letters. I need two letters. Letters, not one. I need two. Don't give me one. And I need those letters to be different. So don't give me YY or RR. No, I need a Y and an R. Different. I don't know why I'm doing this. Boom, different. Probably misspelled it anyways. All right, anyways. Right here. This one's only going to have two possibilities. So we're going to be able to cross out two rows. Mr. Big Y here, he can't go with the little y, but he can go with either of these two little r's. That's one. So big Y, little r. That's one possibility. And also, we have another possibility. Mr. Little Y here can go with either one of these two little r's. They're the same. So it doesn't matter which one because they're both the same. So get in there. Boop. Why do you do that? Why do you do that? All right, there we go. Boom, boom, boom. So another combination is little y, little r. Now, if you want to do it again, if you want to do another big Y, little r, and another little y, little r, you can if you like wasting time, but you don't have to. Since this one and this one are the same, and this one and this one are the same, cross two of them out. We don't need to do those extra boxes. It's just extra time wasted. All right, now how about the other guy? Let's see over here. And this one also, since these two Y's are both little, we're going to be able to cross out two of the rows because there's only going to be two possibilities. Since these are both little Y's, one of the little Y's can go with the big R. That's one combination. Little Y, I'm going to write it. Little y, tiny, with a big, gigantic R. All right. Now, either one of the big Y or little Y's can go with the little r. All right. So, little y. Let's go back to red. Well, little y can go with the little r. Now, once again, you can do another little y, big R, another little y, little r. But why? We don't like to waste time. None of us do. So, cross those out because they're going to be repeats. All right, now let's fill in the boxes. This one's going to be, get the keyboard, big Y, get that thing out of the way. Big Y, little y. Notice how I made that little y tiny, because Y's, they look the same. So, you got to make them really small and really big. R's look different. Big R, little r. This one's going to be little y, little y. From the left, we got a big R. From the top, we got a little r. And then we go over here. Big Y from the top, keep the big letters in front. Little y, little r, little r. And we got little y from the top, little y from the side, little r, little r. Notice how I'm keeping the y's together and the r's together. Will it be wrong? No. But when you start having to count these things, if you have your y's and r's all jumbled around, it makes it way harder to count them. Anyways, genotypic ratio. Grab my drawing tool. How many of them have the genotype big Y, big R, little r? I see one. Only one. It's this guy right here. So on average, 1 out of 4. 1 out of 4 will have the genotype of big Y, big R, little r. If we had filled in all the boxes, if we didn't cross any out, it would have been 4 out of 16. But guess what? When you reduce 4 out of 16, it's the same as 1 out of 4. So we get the same exact answer. All right, so now I get my drawing tool. I'm going to cross this guy out because I don't want to count him again. I don't even have to look at him anymore. Now this guy, little, big little. There's only one. 1 out of 4 again. 1 out of 4 will have the genotype of little, big, little. I grab my drawing tool. I want to cross them out because I don't even want to look at them again. Go back over here. All right, now we got big, little. This guy right here, your drawing tool. I'm looking at this guy. There's only one that has that genotype. So on average, with these two plants, 1 out of 4, 1 out of 4 will have the genotype of big Y, little r, little r. Well, notice once again, I'm keeping my Y's together and I'm keeping my R's together, and I put the big letter first. And the last one, the guy on the bottom right, he's going to have the genotype 1 out of 4. 1 out of 4. We'll have the genotype of little. All right, now phenotypic ratios is just what do these plants look like? This guy right here, he's got a big Y. Boom, he's going to have yellow seeds because that's dominant. He's got a big R. He's going to have round seeds because that's dominant. So that guy's going to be 1 out of 4, and he's the only guy because this guy's going to be green and round. This guy's going to be yellow and wrinkled. This guy's going to be green and wrinkled. So there's only 1 out of 4 that's going to have that phenotype. 1 out of 4 will be yellow seeds and and round, yellow and round seeds. How about this guy right here? Okay, he's got 2 little Y's, so of course he's going to be green. He's got 1 big R, so he's going to be round. So it's going to be green and round phenotype. 1 out of 4. 1 out of 4 will be green seeds and round seeds. This third one, he's got 1 big Y. That's all you need. So he's going to have yellow, 2 little R's, so he's going to be wrinkled. So 1 out of 4. 1 out of 4 will be yellow and wrinkled. And the last guy, little y, little R, little R. Obviously, 2 little Y's means you're green. 2 little R's means you're wrinkled. And there's only 1 of them with that genotype. So only 1 out of 4 on average. 1 out of 4 will be green and wrinkled. All right, let's try one more. Let's see, what time is it? Yes, I got time for one more. All right, I'm at lunch right now. Anyways, let me type because I'm going to forget. I'm going to type the alleles again. What are they? Yellow, green, round, wrinkled. All right, so I'm going to type this. So I remember Y, because I can't see it, equals yellow. What is it? R equals round. Little y equals green. And little r equals wrinkled. Boom. All right, now I don't have to keep going like beep, 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 beep. I can just keep it right here. All right, here we go. Step number 1. Turn the parents. I need to turn heterozygous yellow into 2 letters. I need to turn hybrid round into 2 letters. All right, here we go. Heterozygous yellow. Heterozygous means the same as hybrid. It means round. It means different. So I need 2 different Y's. Big Y, little y. All right, now we still need to know if it's wrinkled though, or smooth, or round. Hybrid round. What does hybrid mean? It means different. Big R, little r. Boom. I got this guy on the left. I got his genotype. Now we got to get this guy on the right, his genotype, or her, whatever. Heterozygous yellow. Heterozygous means different. So I need big Y, little y. Wrinkled seeds. You can see up there that wrinkled is recessive. So the only way you can have wrinkled seeds, you got to have little r, little r. Yay, I got the genotypes of the parents. Now a tough one. Now, if you notice here, this genotype right there, big Y, big R, little r. Since they're heterozygous in both, since all the letters are, it's like big, little, we're not going to be able to cross any out because we're going to have 4 different allele combinations. So let's start with a big Y. Don't give me Y, big Y, little y. No, don't give me that. The Y's do not go together. I need a Y and an R. I need 2 different letters because that's Mendel's principle of segregation. You do not give both alleles. You give one or the other. So the big Y can go with the big R. All right, that's legal. Big Y, big R. All right, now who else can the big Y go with? You already went with the big R, and he can't go with the little y, but he can go with the little r. That's legal. So big Y can go with little r. Big Y, little r. Now we're done with the big Y. He's done. There's nothing else he can go with. But how about, don't forget about little Mr. Y here. Let me change it to blue. Little y can go with big R. All right, let's put that in. Little y can go with big R. And the last one, don't forget, little y can also go with little r. Those are the 4 possibilities. Little y, little r. Boom, we're done. I know this guy's gonna be better because he's got 2 little r's, so we're gonna be able to cross out 2 of the rows. All right, so let's start with the big Y. Big Y can go with either one of the 2 little r's. They're both the same. So big Y can go with little r. Big Y can go with little r. Oh, I went wrong way. Sorry. I gotta put it over here. Big Y can go with little r. And that's it. You can do big Y, little r again if you want to waste time, but you don't need to do that. So let's just go ahead and do the next one. Little y can go with little r. Little y can go with little r. That's it. Those are the only different combination of y's and r's for this genotype. Big Y, little r, little y, little r. All right, so you can take your drawing tool and you just cross these out. It makes it so much easier. Please tell me that box is not going to be in my way. Yes. All right, so now let's just fill in the boxes. Oh, we got big Y. Get that thing out of the way. Big Y, big R, little r. Ooh, barely fits. Do like this. Big Y, this one, and big Y, little r, genotype. Big first, little, big, little, heterozygous in both. Big, little, doink, 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 doink. We got big from the top. Keep the big ones first. Makes it easier to count. Big Y, big R from the top, little r. Boink. We got big Y at the top, little y from the left. And then we got two little r's. And we got little y's. We got a big R from the top, little r from the left. Notice I'm keeping the big letters coming first because it makes it easier to count if you have them nice and organized. Little. All right, there you go. And one more time, genotypic ratio. All right, here we got big Y, big R, little r. Put a mark there. Is there any other ones like that? No. So I'm going to put that 1 out of 8. The possibility is 1 out of 8. 1 out of 8 of the plants will have the genotype of big, little. And now I'm going to cross them out because I don't want to even look at them again. How about big, little? No, just 1. Big, little, there's only 1 out of 8. On average, we'll have that genotype. So 1 out of 8 will be big, little. Now I'm going to cross them out. I don't even want to look at it. I don't want to count them again. How about big, little? There's 1. There's 2. And that's it. 2 out of 8 will be, on average, 2 out of 8 on average will be big Y, big R, little r. And once again, I'm going to cross them out because I don't even want to look at them anymore because it's easy to count them again. And how about this guy? Big, little. There's just 1. On average, get out of there. 1 out of 8. 1 out of 8 will have the genotype of big Y, little R, little r. And we only got 2 left. This guy right here, little, big, little. And let me cross this out so I don't look at him. Little, big, little. There's only 1 of them. 1 out of 8. Let me go down here. 1 out of 8 will have the genotype of little, big, little. And the last one, I don't need to cross them out because there's only 1 left. Little y, little r, little r. 1 out of 8. 1 out of 8 will have the genotype of little y, little r, little r, little r. All right, what do these plants look like? Phenotypic ratio. All right, this one right here, drawing tool. This one's going to be yellow and round. This one's going to be yellow and round because look, it's got 1 dominant allele, 1 recessive allele, so it's yellow and round. And that's it. That's the only one's going to be yellow and round. That's 2, and then get out of there. 1, 2. 1 plus 2 is 3. 3 out of 8 will be yellow and round. 3 out of 8 will be yellow and round seeds. All right, let's see another one. See this one. It's got 2 big Y's. It only needs 1, but it's got 2. So it's going to be yellow. It's got 2 little R's, so it's going to be wrinkled. Yellow and wrinkled. Any other ones going to be that? This one here as well. Oh, yeah, I'm on this one. Yellow and wrinkled, and that's it. 1 out of 8 will be yellow and wrinkled. 1 out of 8. 1 out of 8. Yellow and wrinkled. All right, let's go to the next guy. How about this guy? He's got 2 little Y's, so he's going to be green. He's got a big R, so he's going to be round. So he's going to be green and round, and there's only 1 of those guys. 1 out of 8 will be green and round. 1 out of 8. Green seeds and round seeds. And the last guy here at the bottom, little. Of course, 2 little Y's means you're green. 2 little R's means you're wrinkled. So on average, 1 out of 8 will be 1 out of 8 will be green and round. Now, I think I screwed up here. Let's see. I did screw up somewhere. Where did I screw up? anyways, I screwed up somewhere, and you guys could probably figure it out. And the way I know I screwed up with my counting somewhere, because look, if you add this up, 3 plus 1 plus 1 plus 1 equals 6, where it should equal 8. So somewhere along the way, I screwed up. Now I can go back and fix it, but lunch is about ready to end. So, hey, you go back. I screwed up somewhere in here, because you can look at these. 1 plus 1 is 2, 4, 5, 6, 7. I screwed up here too somehow. This should equal 8 out of 8. So I screwed up. A row so screwed up. But hey, if you screw up like that on the test, you're going to get almost all. If it's worth 12, I'm going to give you 10 or 11. Because that's just, you just messed up counting. The main part is be able to find the genotype of the parents, find their allele combinations, there and there, and then fill in the Punnett square. If you do that correctly, heck, I might even give you full credit, because I know it was just a little careless mistake. I make them. Everybody makes them. So anyways, I hope this helps, and I'll see you next week.